Hey everybody, thanks for having me. My name is Kara Kukuritis and I work at RiversEdge West. We are a nonprofit that's actually based here in Grand Junction that is focused on restoring riverside habitat throughout the West. And just wanted to thank y'all for having me today and bearing with me through a virtual talk. I'm sorry that I can't be there in person, but hopefully you will walk away from this little presentation with a little more knowledge about our rivers and some of the impacts that they are facing. And really what I'm going to focus on is actually more so the vegetation along our rivers and some of the invasive plants that are impacting these places. So I'm going to go ahead and share my screen here and we will get started. So, all right, I like to start with this photo because it really hits home for me the value of these places that I'll be talking about today. I'm sure that you probably have learned this already, but those two green strips of vegetation running alongside of that river is called the Riparian area. It's just another word for riverside habitat. And these places I just love this photo because we have this arid desert southwest on either side and then this lush green habitat in the middle. And these places are typically referred to as ribbons of life, and you can kind of see why, because they support incredible amounts of plant diversity. It's so rich and abundant, and because of that, it can sustain so many different types of wildlife. And one thing that I found interesting when I was learning about this work is that really only about 1% of land in the United States is actually considered riparian habitat, but almost all wildlife will rely on these places at some point in their lifetime. So whether they're just migrating from one place to another over the winter and they need some place to stop for food and for shelter, or they're living there their whole lives, really almost all wildlife will depend on these places at some point. So to me, it's critically important that they have the plant diversity and the types of shelter that these wildlife are looking for, that they need. And one unfortunate thing is that a lot of this riparian habitat has been lost since pre-settlement conditions. So it's pretty unfortunate. So a lot of our work just focuses on protecting and maintaining these riparian habitats. So what do I mean when I talk about a healthy riparian habitat? I wanted to show you a photo that gets a little more specific about this. This is our goal here. We want to return riparian habitats to something along these lines. It's kind of easier to see in this photo because it's taken in the fall, so you kind of have those distinct colors to point out. But you know, the next time you pass by a river or a waterway, or hopefully you get to actually go on the river itself, you can decide for yourself if you think that river has healthy riparian habitat. And the way that you do that is just by simply taking note of how many different types of vegetation do you see along the river. The more plant diversity, the more types of plants you see, the better. And really each of these layers, those 3 stories of vegetation, are providing very different, unique types of habitat for wildlife. So in that first layer, you're gonna see those taller grasses. In the second level, you'll have those medium-sized shrubs like woody plants. And then in the third layer, we've got your taller, mature trees like your cottonwoods. So again, each of these places are providing different habitat for tons of different types of wildlife. So, you know, for me, it's that you kind of look at this and it's like going to a buffet. You have all the different food options to choose from. It's pretty nice. But the problem at hand is that invasive plants like tamarisk and Russian olive, they've invaded these areas and they are out competing these native plants. And when they invade, they create these dense thickets along the riverside habitat. So you completely lose this plant diversity. It's like going from a buffet of food to choose from to going to have to eat saltine crackers for the rest of your life. So I'm going to show you one more photo of a healthy riparian habitat. This one was taken in the summer in Neon Canyon in Escalante. And again, you can still see here that we've got in that first layer down in front some grasses. The second story has some nice shrubs, and then up at the top in the back is some taller, mature cottonwood trees. So again, really great diverse habitat here. And you can also notice that you've got great access to the river for people and wildlife. So this can be a big issue in communities like ours in Grand Junction when you've got riverfront trails and properties, but they become thicketed with invasive plants that you actually can't access the river. So these native species allow for access and allow the river to move, which is great. This next photo I'm going to show you is taken in the same place. So you can look at that top right rock in the corner as your photo point. And this is what happens when an invasive plant like Russian olive moves in. I'm sure maybe some of you have heard of Russian olive and tamarisk, but we'll get real up close and personal with these guys today. So when Russian olive moves in, look at the difference in the riparian habitat. Holy cow. So we have lost that plant diversity, right? Now we just have one thicket of densely packed Russian olive trees. Russian olive, by the way, has very, very long thorns, so don't get too close to them. We've lost access to the river, and it's actually shading the river. It changes the chemistry in the stream, and it also starts to hold the banks in place. So it begins to channelize the river. So you have fewer side channels that are able to open up and get created, which is really great for fish habitat. So again, we have our healthy riparian habitat that gets invaded by our invasive Russian olive. And in the case of tamarisk, which we'll learn a lot more about today as well, it looks very similar to Russian olive in the sense that it just creates these very dense thickets along the riverside. Pretty dramatic landscape scale impact. I do want to back up and mention that there are many different types of invasive plants that we manage, as well as an array of native plant species that we try to restore these areas with. And for native plants, we want lots of different types of willows. Cottonwood trees obviously actually provide some of the best habitat in galleries for a lot of our wildlife, like larger birds of prey, like owls and hawks. This is critical nesting for them, and it just changes the whole climate down there. So four-winged saltbush, lots of different species out there that you can really think about planting when you're restoring these areas. And when we talk about our invasive species, we're not just mentioning tamarisk and Russian olive, although that's what I'm focusing on. There's so many others, tree of heaven, cheatgrass, kochia, Russian knapweed. The list goes on. Unfortunately, there have been a lot of plants that have been introduced, whether it's intentionally or accidentally, that have many advantages that allow them to outcompete these native species and really take over. So there's a lot out there. But when we do talk about tamarisk, I wanted to give you a little background as to how it got here. So really, like many invasive species, tamarisk was brought over in the 1800s for erosion control, and because it was pretty, it's used as an ornamental, and it was also used as windbreaks. But people quickly realized that before long, these plants had started to invade places that they never expected and were pretty persistent and stubborn and difficult to get rid of. So tamarisk itself, it comes from Asia and northern Africa. And really, in a lot of places out here, it has replaced about 50% to sometimes, in some places, 100% of the native vegetation. So one other thing I wanted to mention in terms of setting the stage for the invasion of these invasive plants, not only did we introduce these plants ourselves, but we have a lot of things that we have done to our environment and the flows in the river that have made it a lot easier for these plants to invade. So I'll talk a little bit about that real quick. So, historically, we have in the springtime, you've got, the sun starts to melt the snow in the mountains. The water begins to fill the river. The snow melt begins to raise the level of the river, and then it begins to overflow the banks, which is really good. That's what historically has always happened. There's been a lot of variability, big flood events, and then it drops down to a lot less. And when it does this, when it floods the banks, when the water floods the banks, it actually helps to flush out a lot of accumulated minerals that build up over time. So it helps to kind of cleanse the soil, which is really great. But, you know, since we have developed so much of the southwestern US to sustain life out here, you know, in Grand Junction, in Phoenix, Las Vegas, LA, all these places, you know, there needed to be a way to store and regulate water. So that meant building dams and reservoirs and regulating our flows. So that has had a big impact on our native species. I'll show you a little hydrograph in just a second here. But, you know, a couple other things to mention is that without, now that we don't have these big flood events anymore, we don't have the flushing out of the minerals that build up on the soil. So you get a lot of minerals like salt that builds up. And unfortunately, our native species, they're not adapted to salty soils. They have a hard time germinating. And just to give you a rough idea, it's kind of hard to conceptualize, I think, but you know, cottonwoods can withstand about 2,000 parts per million of salinity in the soil, whereas tamarisk and Russian olive, these invasive species, they can withstand easily 36,000 parts per million of salinity in the soil. So now that we have less frequent and intense flooding, we've got the buildup of these salts, which makes it a lot harder for these native plants to thrive. One other interesting thing I think is that, I don't know if any of you have ever noticed when cottonwood seeds drop from cottonwood trees, when you start to see those little white seeds falling from the sky. But typically that happens in the spring. And cottonwood seeds drop their seeds in the spring because normally they know that this is when the runoff happens. And cottonwood seeds need the damp banks to germinate. They need the soils to be saturated. And unfortunately now, without these flood events like they used to be, we're not seeing as many cottonwoods being able to germinate. We're not seeing as many young cottonwoods thriving. So a lot of different impacts here, in addition to us having introduced these invasive species. And this is going to be definitely the craziest slide that I'm going to show you today, but I think it's pretty cool to see this. This is a hydrograph from Lee's Ferry. This is the amount of water that is flowing through Lee's Ferry at any given time from 1928 to 2012 here. So those blue spikes are the amount of water in cubic feet per second that is flowing through Lee's Ferry. So from 1928 to about a little before 1964, you can see here that we have these really big spikes in runoff, and that's your spring runoff happening when the river is starting to fill and the banks are starting to overflow, which is great. You might notice here around 1964 that there was a big drop in this hydrograph here. The water takes a big dip, and that was when they were filling up Lake Powell. And you also might notice another spike over here, just in this area, and that is from a big flood in '83. I don't know if any of you, I guess you guys may not have been born then. Geez, that's weird. But in '83, there was a big flood, and you might actually notice too that a lot of the cottonwoods along our riverfront in Grand Junction have about the same diameter because they were all products of that big flood event that overflowed the banks finally and helped all these cottonwoods to germinate. So anyways, that's the flood. But what you can really take away from this slide is look at what happens after we dammed the river, filled up Lake Powell. Look at how much less natural variability we have. All of a sudden, these huge flood events are pretty much no more, very infrequent. So we still have flows, but just not the kind of flows that we used to have. So again, just to keep that in mind, that not only is it hard to restore riparian habitat back to what it used to be, it's really hard to do it now that we don't have the natural flows that we used to have. So it involves a lot more strategy with where you're planting cottonwoods, making sure that if you do plant a cottonwood tree, that it's all the way down into the water table. Otherwise, it's really going to have a hard time surviving. Also making sure that when we can, we're coming back to these sites to water the plants as much as possible, which isn't always possible, but we try to when we can. So All right, so moving on, a couple other things I wanted to talk to you about are just some of the impacts of tamarisk specifically. So we know I've mentioned already, probably ad nauseum, that it decreases plant and wildlife diversity. But the other thing I wanted to mention is that it does really impact farms and ranches. It can really reduce the value and the productivity of land. And, due to the dense thickets that you're seeing in these photos and from probably what you've seen in your own experiences, you can tell that people can no longer access riverfronts when they've been invaded with these thickets of invasive species. And boaters often find that their former campsites, if left untreated, can be overrun by invasive plants and you can't even access them anymore. So this actually, the photo on the bottom left is from the San Juan River trying to access an old trail that leads to some pretty cool petroglyphs along the river, but you could barely get to them because the whole trail had been invaded with tamarisk. This gal over here, she's actually going down to the river to sample some water quality data, but really you can't even tell there's a river on the other side because tamarisk has thicketed out so heavily. So a couple other things, you may have heard that invasive plants consume more water than our native species, and that really is true. One thing to note though is that tree for tree, tamarisk versus a cottonwood tree, they actually consume about the same amount of water. It's about 20 gallons a day. But with tamarisk erosion, all of these invasive species, when we have one tamarisk, we have thousands of them growing in a riparian area, where historically you wouldn't have that densely packed vegetation. So in their sheer numbers, they are consuming more water than our native plants. And they also have huge tap roots that allow them to survive on the upper benches of the floodplain, where normally you'd have more xeric species like sagebrush or rabbitbrush that consume way less water. I'm going to show you a really exciting animation here, thanks to our friends at NASA, that'll just kind of drive this point home. So on the left-hand side, we've got our cottonwood tree and its modest root system here. In the middle is our strangely colored river. And then on the right-hand side is our tamarisk tree. And just look at the roots in comparison to our cottonwood. Down below here, this like gray line is supposed to represent the water table. And you can see here that the tamarisk easily reaches into the water table as well as into the river. So again, what we'll see is that the tamarisk starts to populate the riverside habitat. We've got a cottonwood here and a cottonwood here, but with all of these tamarisks now infiltrating the river system, it brings down so much water that this cottonwood doesn't have the sizable roots to continue to access that water. The water table drops, and you often see species like cottonwoods that die out as a result. So pretty unfortunate. So another interesting thing, I think, is that you might have heard tamarisk being called salt cedar before, and it gets its name salt cedar because of its ability to actually make the soil saltier. So it really stinks, but I'll show you another NASA video of how this happens. But with those really deep root systems, the tamarisk plant, along with pulling up water, it also pulls up salts from way down in the soil profile. And when those salts get brought up into the plant, the salt gets deposited into the leaves of the tamarisk plant. And what happens in the fall time to all the leaves on the trees? Those leaves fall, those salty leaves fall to the ground, they break down and decompose and add that salt to the top layer of the soil. So it further accelerates that salty soil that we really don't want for our native species. So again, here's our little video. Here's the tamarisk roots. Those white dots are going to be the salt being brought up through the tamarisk roots. And then you can see as the salt gets deposited into the leaves and they fall, now that top layer of soil turns white, representing it all turning a lot saltier. Pretty unfortunate. So, all right. Last thing I believe that I wanted to mention about these impacts is that, and pretty relevant to unfortunately what we're all experiencing right now with the Pine Gulch Fire and the Grizzly Creek Fire, is that that these invasive plants really increase the frequency and severity of wildfires. So as you can imagine, all of a sudden we have these dense thickets of tamarisk and Russian olive along our riparian corridors. They blanket these areas, essentially creating a fuel ladder for fire to spread down the whole corridor. Normally you would have a riparian habitat with a few big cottonwoods and some shrubs in between, but there wouldn't be such densely packed vegetation that if a fire were to break out over here, it wouldn't really carry and travel down the Riverside corridor to the next group of cottonwoods. So you'd have more isolated, smaller, less severe fires. But with obviously these invasive species, it's a whole different story. I want to show you this photo here. You might recognize this depending on how long you've lived in Grand Junction, but this is actually on I-70 if you are heading east towards Denver or towards the Grand Mesa. This is in CMU at Island Acres. And really this fire was made a lot worse because of the densely packed tamarisk that was blanketed in that corridor. And the unfortunate thing about this is that tamarisk actually, in timed ignition trials, it burns hotter and it ignites faster than our native plants. It has more to do with the surface to volume ratio of these plants. It accelerates moisture release from the leaf tissues, and it speeds the rate of ignition and combustion. So again, once these areas that were once barriers to fire are just becoming pathways for wildfire to spread. And unfortunately, our native species, after a fire does come through, the fire is now burning so much hotter that it basically girdles the plant, the cottonwood tree, where it kills off like the living layer of the cottonwood, making it virtually very difficult for it to survive. And unfortunately, again, the tamarisk plant is very adapted, as you might have guessed, to fire. You know, in just a year's time, it can grow a couple feet right after a fire has happened. So this is just a few months after a fire has come through. The tamarisk here is clearly resprouting with a lot of vigor. So, but fortunately, you know, there are a lot of ways that we are working to control these plants. So all hope is not lost. It is a really big issue, but RiversEdge West and a lot of organizations across the Southwest are focused on eliminating and managing the spread of these plants and returning these corridors to the healthy ecosystems that they once were. So we'll go in and plant native species. Sometimes the plants will just regenerate on their own, but I'll walk through just a couple ways that we work to remove them before we wrap up here. So the first method is mechanical removal. So we hire local contractors and youth conservation corps members who get out there and remove those plants. They have, you know, chainsaws and heavy machinery, hydro axe, excavators, all different types of ways to remove these plants. A lot of the times we'll be working in more remote areas. We have a partnership on the Dolores River that we coordinate, the Dolores River that runs like through Gateway area, really beautiful, but a lot of those places are pretty remote and hard to access. So we'll primarily work with Conservation Corps crews who will use chainsaws. But essentially, once you chainsaw or mechanically remove the plant, if you don't get the root system, that thing is going to come back like you never touched it. So after we take off the top of the plant and the roots are still intact, we have to come through and apply an herbicide that will actually, that blue stuff is the herbicide, a chemical that actually seeps down into the root system and kills everything below, like everything in the roots below ground. And, you know, I know at least when I hear about applying herbicides along rivers, it isn't great news to me, but fortunately these have a short half-life. They break down pretty quickly, so you don't get as much runoff into the river. Plus it's great that it's a direct application just to the stump. So, and honestly, you'll have to come back and apply this herbicide sometimes a few times. Sometimes you'll still get regrowth from this even when you apply the herbicide. So it takes years of continued maintenance of coming back to these sites and continuing to treat these. It's not like a one and done kind of deal. It's a long-term commitment. So, so the third way to manage tamarisk is pretty cool, I think. I don't know if any of you have actually heard of the tamarisk beetle, but basically when settlers brought tamarisk over from Asia in the 1800s, one of the things that they didn't bring with them was a natural predator of tamarisk that would help to keep its population in check, right? So you've got this tamarisk plant that has nothing to hold its population in place or keep it from going bonkers. So after massive amounts of research and testing, the US Department of Agriculture released the tamarisk beetle in 2001 to help control the spread of this plant. So there's a little picture of it here. And the good news is that it's a specialist. It's only eating tamarisk. It doesn't eat any other plant. And there's no plant similar to tamarisk in the United States where it would jump host and eat something else. So it's doing a really good job at what it's been intended to do. And at RiversEdge West, we don't release the beetle, we just monitor the spread of it. We help land managers and landowners prepare for its arrival, because as you'll see here in a second, it has a pretty huge impact on the riparian ecosystem. Here's another picture of it. I'll show you a bigger one of that in a minute. But again, here is a thicket of tamarisk. You can see it's just this monotypic stand of tamarisk, just one plant, no plant diversity here. This was taken along the Colorado River outside of Moab. And in 1 month's time, the tamarisk beetle will move through and look at the after photo of what it does. So it defoliates, it eats the leaves of the tamarisk plant, and essentially it weakens the plant. It will come back and do this year after year and help to control the spread of this plant, which is really great. So again, here's their hungry teenager phase. They go through a complete metamorphosis. So this is what they look like when they're in their larval form. And then they drop down into the leaf litter and come back out as adults. Pretty crazy. Now these guys are out in the Grand Valley as well. They're all across the Southwest. I'll show you a map of that too. But you can, the next time you're out along the river, especially during the spring and summer months, I would totally go down and check out some tamarisk and take a minute to see if you can find some tamarisk beetles feeding on some tamarisk out there. You'll probably be able to find some. They don't bite, so if you're like not a bug person, they're actually pretty cute. So really what we're looking at here is that we've got this tamarisk in our riparian systems. They've introduced a biological control, this tamarisk beetle, to feed on the leaves of the tamarisk plant. So when it's done, they often look like this. Now, you would think that this plant would be dead after that, but of course, tamarisk is way more resilient than that. So it uses energy reserves that it has stored in its root system to leaf out again. And it looks a little different than what it did before. It comes back with what I call like little poodle puffs. So just these little puffs of tamarisk leaves here. You can tell it doesn't come back with as much vigor as it did before. And fortunately, oftentimes the tamarisk beetle will come right back, feed on that tamarisk plant again, and eventually this will happen enough times that the tamarisk will not have enough energy reserves left to keep leafing out again and again and again. So eventually it can kill tamarisk. The other thing that's really neat is that instead of the tamarisk plant putting energy into producing all these seeds and flowers, it's now putting its energy out into just putting out new leaves. So it really helps to lessen the spread of tamarisk because it's not putting out as many seeds into the environment. And what we're really seeing here over time is that with these repeated defoliations, the tamarisk will die out, and it creates these, I kind of think of them as like elephant graveyards from The Lion King for some reason, but you have these like old thickets of tamarisk here, and finally the floor of riparian habitat gets enough sunlight and has more water that these native species, like what you see here, this is a native New Mexico privet, has come up through the understory of these tamarisk skeletons. And these plants, these tamarisk old dead plants, they start to get really thin and they break off in the wind. So they eventually kind of take care of themselves in a lot of instances. So really good thing that's been happening. I want to show you, just to give you some perspective of where these beetles are in the Southwest. We do map the tamarisk beetle, so I wanted to show you a map here. The red dots are some large establishment of beetles. This was in 2007 when we first started monitoring the beetle. You can see that it's all in Utah and Colorado. And then there was an illegal release out here in Utah. very southwest Utah. And this was a pretty unfortunate event because it did put the beetle smack dab in some endangered bird habitat. So there are some birds that have adapted to live in Tamarisk now that their native habitat, like willows, have been replaced. So I'll talk about that in a second, but I think that's pretty important to kind of keep in mind. So we'll go through the years here. So obviously we're going to start to see the Tamarisk beetle spread primarily just along our river systems. So now we're in 2010. And you can see it's kind of moving north into Utah, and now that illegal release has spread into Nevada here. And then moving forward, 2011, the data presentation has changed a little bit. So the blue is just the year 2011, and it goes all the way to the red in 2007. So you can kind of track it year by year. In 2015, and some of these have been intentional releases. The Palisade Insectary is actually in charge of allowing folks where they can release the beetles and where they can't. So some places have actually had approved releases of the beetle in some of these states. And going to 2017, you can see here. So this is, I think, the last map that I have on this presentation, but really you can just see all of the turquoise dots are from 2017. And, you know, just to give you that idea that it really is all across the Southwest helping us to do this. So as I mentioned, there were some unintended consequences to introducing the beetle. And the big one really is just the impacts to these endangered bird species. So the southwestern willow flycatcher and the yellow-billed cuckoo are birds that primarily nest in willows, but now that the willows have been replaced by tamarisk, we are seeing them nest in tamarisk instead. But the issue is that when the tamarisk beetle comes through and defoliates the leaves of the tamarisk plant, if one of these birds is nesting in tamarisk, all of a sudden the leaves are gone and it exposes the nest to predators and to the sun. So you have really high temperatures now beating down on those little eggs. So you can really see some mortality in some of these bird species, unfortunately. But the good news is that overall, studies have shown that there is higher reproductive success when they're nesting in willows versus tamarisk trees. So it just makes the case of why this work is so important, that we get in there, remove patches of tamarisk, replace them with the native species so that these birds can nest in these places instead. We also know that there's a bird called a cowbird, and it's pretty crazy. It follows cattle, so it doesn't really stay in one place to raise its young. And the cowbird, it actually lays its eggs in nests of other birds. And it's pretty wild because the birds, like the flycatcher, has a new baby in it, but it actually doesn't realize that the cowbird is not its own baby. And the flycatcher will feed that baby and it'll survive. It's a lot bigger than the other one, so it'll get more food, and a lot of times the flycatcher's babies will die and the cowbird baby will survive. So kind of a side story here, but basically these the cowbird attacks on flycatchers are a lot higher in nests that are in tamarisk than when they're in willows, because tamarisk doesn't have as much protection than our willows do. So overall, it's unfortunate that these birds are being impacted by the tamarisk beetle, but we know that it is better for the birds in the long run to get rid of tamarisk and replace them with their native habitat. So all right, so overall, I just wanted to wrap up here and just kind of summarize that essentially we know that biocontrol, like the help of the beetle in combination with other stuff that we're doing with mechanical removal and revegetating these areas with native plants, really can help move these riparian ecosystems towards a healthier state, to be a more functional community. So it is a good thing. And really some of the things that we do at RiversEdge West to help with this, there's a lot of components to this work. It's not just about taking out the invasive species and planting native plants and walking away. You need money to do that. So one of the things that we do at RiversEdge West to help advance this work is we do a lot of fundraising and planning for this work. So we write a lot of grants to fund restoration, to hire conservation corps crews to come out and do this. And we gather people together who own and manage land along the rivers to work as a team. It's a lot more efficient to apply for funding as a group than to apply for funding as one private landowner. So we kind of bring all the heads to the table to kind of push this project along at a larger scale. We also actually coordinate and advise how to remove these invasive plants. And a big part of this too is making sure we are doing research on how to best revegetate these areas with native plants, especially with times with the changing climate. What species of plants are going to be good? Maybe not now, but maybe in 10 years from now. So that's a big part of what we do as well. We have a big education program where we host an annual conference every year. We bring together over 200, 250 riparian restoration practitioners and land managers to all share what we've learned in our projects and learn from each other to make our work more efficient. And then a big part of what we do really is trying to get the community involved, be stewards of this work. So, you know, this won't be as effective if we don't have long-term commitment to care for this. So we've got a youth education program. We've got kind of a rolling volunteer program to help continue to maintain these sites. So I would totally suggest if you're interested at all in this stuff, we've got most of the social media stuff going on: Facebook, Instagram, YouTube, LinkedIn. So definitely check us out and follow us to stay informed about the events we have coming up. So if you're ever interested in joining us. And with that, I'm just going to show you a couple of our projects that we've done that you might be familiar with. This one is just along Monument Road when you're heading to Lunch Loops. So we have a bunch of tamarisk. You can tell all this brown tamarisk here has been obviously hit by the tamarisk beetle. It's pretty cool to see. And so we removed all that tamarisk here in the after photo in 2016, and we left all that native vegetation here. So it looks a lot better. And then another one here is in Indian Wash, where we've got, in before 2014, we've got mostly tamarisk cover, not much understory. Doesn't look great here. And then we removed the tamarisk, and in 2016 afterwards, we see here that this site all came back on its own with all these native grasses and willows. So it's pretty cool to see. As I mentioned before, our work really does span across the West. So all the blue dots are partnerships that we lead. We actually take the lead role in coordinating funding and work and hiring the conservation corps crews in the whole gamut of restoration. And then the green dots are other watershed partnerships that are doing similar things to what we're doing that we also support. So we help them by providing them with technical assistance or funding assistance or workshops, you name it. So the great news is that there's a lot of other organizations out there along with us at RiversEdge West that are addressing these issues and working to restore these ecosystems. And lastly, I will say I'm not going to play one for you today, but we did make a really cool video series called the Riverside Stories that kind of profiles for people who are working on restoring rivers, folks that we work with basically, and we wanted to help raise awareness about this work and do it in a way that was enticing and a little less scientific and boring. So really would encourage you guys to hop on our website to check some of these out, or on our YouTube page too, because it's one of my favorite projects for sure. So with that, I obviously won't be taking questions directly, but just wanted to thank you for listening, and again encourage you to follow us on our social media, sign up for our newsletter, and if you do have questions, I hope Kate can send them to me and I can get those answers back to you somehow. So thanks again, and hope you guys have a great semester.